All right, boys and girls, welcome back to the drive-through. Hope everyone's having a great day. Welcome to Chapter 2. Hopefully this is the second video you've watched. You've already checked out that Desmos video that I posted above this one. That was just a quick 3-minute video. You're going to see us using it here in this video. It's very useful too. So, I got a little sister, Savannah. She's 3 years old, so everything's a big deal to her, and she only has 5 pennies. She started with 5 pennies. Well, that means on the 0th day, before we have even started this thing, she has 5 pennies. And what that's going to be, if you can think about what we've already learned, that's going to be our y-intercept. Okay? Now, every day I come home from school, I have 3 cents left over from my lunch, whatever. So on the first day of school, I've given her my 3 pennies. Now she has 8 pennies. On the second day of school, she now has 11 pennies. Third day of school, she now has 14 pennies. Okay? It says use a table, a graph, and an equation to create a mathematical model for the number of pennies in the piggy bank. So here's my table. My graph, well, every time I go over 1, I go up 3. And let's see, what is this equation? Well, what's going on each time? We're going up 3. Over 1, up 3. Over 1, up 3. Over 1, up 3. That's our slope. Well, m, what is that from? Y equals mx plus b. Well, in this case, it says use a table or graph equation to create a mathematical model for the number of pennies on day n. Well, that means for this one, it's going to be y, or f of n, we could write it, is m times n plus b. I know that's confusing, but if you like this more, then just use this. I don't care. I just want you to understand what you're doing. Ideally, you could use both of them. Okay? So what is our b? Well, our b is our y-intercept. And so that's where we begin. Well, we begin with 5 pennies. So our equation is y equals 3x plus 5. Or our function of n is 3 times n plus 5. They're not asking for a recursive formula, so we can move on. Okay, our family has a small pool for relaxing that holds 15,000 gallons of water. Decided to fill the pool for the summer. When I had 5 gallons of water in the pool, I decided that I didn't want to stand outside and watch the pool fill, so I had to figure out how long it would take. Oh, this could actually be realistic. I checked the flow on the hose and found that it was filling the pool at 2 gallons per minute. Okay, so what they're saying here is when I had 5 gallons of water in the pool, we started. So we're going to start this little experiment with 5 gallons of water in the pool. I checked the flow on the hose and found that it was filling the pool at a rate of 2 gallons every minute. So after 1 minute, we're at 7. After 2 minutes, we're at 9. Okay, so what is this? Our common difference is 2, so our slope is 2. Our y-intercept is 5. It's where we begin. Use a table, graph, and equation to create a mathematical model for the number of gallons in the water pool at t minutes. So now this is y equals 2x plus 5. But in this, instead of a function of y or a function of x or a function of n, they want f of t. A function of time is 2t plus 5. Let's see if that works. 2 times 3 is 6. 6 plus 5 is 11. That does work. I'm more sophisticated than my little sister, and I save money in my bank account that pays me 3% interest on the money in the account at the end of each month. If I take my money out before the end of the month, I don't earn any of the interest. Okay, so that means however much money we have in the bank, we're going to keep it there for a month, and they'll pay us 3% more than we have in there at the end of the month. I started the account with $50 that I got for my birthday, using a table, a graph, and an equation to create a mathematical model the amount of money I will have after N months, or M months. Well, this is going to be significantly harder. So we're going to start with $50 in our account. Now, what is 3%? 0.03. Hopefully you remember that. Well, how do I get 3% more than 50? Well, you know what you do? You can either do 50 times 0.03 plus 50. So I could take 3% of 50 and add it to the 50 that we already had, or you could just do 50 times 103%, which is this. So we're gaining 3% a month. That's what the 103, adding 3% to what we already had. So that's 50 times 1.03, and that's how much we're going to have at 1 month, after 1 month. So let's 50 times 1.03, and that's going to be 51.5. And after 2 months, I'm going to multiply the previous month times 1.03, and now we have 53 point, I don't know, 0.05. I rounded to the nearest cent, and we're going to multiply that by 1.03, and after 3 months, I'll have 54.64. Okay, now, this is great. Notice, how did we get from here to here? We multiplied by 1.03. We multiplied by 1.03. We multiplied by 1.03. This is going to be a geometric function. Well, if you remember these, f of m, the amount of months, is equal to, well, where did we start? We started with 50, and then we multiplied by 1.03 the amount of months that has gone by. So that will give us, so just to give you an idea, if we went over to Desmos, and let's see, clear that one, clear that one, clear that one, and let's write an expression. So if we wrote f of m equals 50 times 1.03, and then to the, sorry, not control, to the m power, graph it. Now, you can't see anything. We'll scroll out. All right, now check this out. There's your graph. And this is how money grows. This is like one of the most important things I could ever teach you. This is the amount of months that have gone by, the amount of M's, months. This is how much money your $50 is now worth. So notice, if we just scrolled up, after 200 months, where is that? Well, let's look at it. Let's look at it as a table. Let's see. Well, oh my gosh, it's so high. It's hard to even find it. Get back to my 200. Okay. Let me scroll up till that line passes over here. Oh my gosh, look how much money we have. This is great. This is great. This is great. Keep going. It's never going to get there. After 200 months, keep going. Keep going. Keep going. Keep going. We have over, our $50 has become, anyway, thousands of dollars, tens of thousands of dollars. Let's learn how to put that in our table. So M, and let's go 50 times 1.03 to the M power. Nope, no help. So we're going to have to go to Desmos and learn how to use the table feature better. No problem. I wonder, let's see. That's not what I wanted. Table. All right, well, we'll learn together. I'm going to keep going back into the rest of these. Okay, back to the swimming pool question. I decide to drain the 1,500-gallon swimming pool. You notice that it drains faster when there's more water in the pool. It's interesting to me, so I decided to measure the rate that it drains. This is a calculus question. I found that 3% was draining out of the pool every minute. Use a table, a graph, and an equation to create the mathematical model of gallons of water after T minutes. Okay, so now, at 0, we start with 1,500. Okay? 3% of it was draining out of the pool. Well, that means 97% of it was remaining. So how do we do? We could do 1,500 times 0.03 subtracted from 1,500, or you could just multiply 1,500 times 97%. Okay, because there's 97% of the water still remains after a minute. So 1,500 times 0.97 times 0.97. After 1 minute, we'll have 1455. After 2 minutes, just multiply that by 0.97. You'll have 1411.35. After 3 minutes, just multiply that by 0.97. You'll have 1369.01 cents. So every time we're multiplying by 0.97, we started at 1,500. So our equation will be f of t is 1,500 times 0.97 to the t. If we wanted to graph that, we'll graph that on Desmos. So let's get rid of that. And let's type in f of t equals 1,500 times 0.97 to the t power. All right, we got to scroll back in. We got to scroll back in. We got to scroll back down. All right, so now you'll see this graph. So notice, where does it start? It starts right at 1,500, and it's decreasing, and it's decreasing, and it's decreasing. And it looks like, if I scroll in real close, it's going to take, well, the water will never drain, but it will be very close to zero after about, let's call it 300 minutes. Okay, but if 3% of the water always remains, that means that some water will always be there. And that's just a little property of exponential growth and decay. Okay, let's see if we got anything else. All right, compare problems 1 and 3. What similarities did you see? Well, they both involve saving. They were both linear. Nope, they both involve saving. They both involved growth. They were both increasing. That's a similarity. A difference is that number 1 was linear, and number 3 was geometric. Okay? The differences and similarities between number 1 and 2. Between number 1 and 2. Well, number 1 was increasing. Number 2 was decreasing. Now number 2 is also increasing. They're pretty similar. They just had a different y-intercept and a different slope. So both of these, the similarities, both were increasing. Both were linear. The differences was the slope and the y-intercept were different. Compare problems 3 and 4. Okay, 3 and 4. Both, well, 3 is increasing, 4 is decreasing. Both are geometric. So, let's see, similarities. Geometric. Differences. Number 3 increases, and number 4 decreases. And I hope you liked the video. Tough stuff. Keep working. Boom!